Hey, if you're having trouble with two-way frequency tables, you need to go back and watch my first video first. If you've already done that, great, but I've got a basic video in this chapter as well that you need to go check out first. If you've already seen that video, though, let's get started. I have on the right-hand side here highlighted the same thing we've been using this entire time, when divided by possible. But this time, we're going to be looking at this with two-way frequency tables as well. If you know how two-way frequency tables work, just one more time, I'll remind you, there are two things that we look at here. First of all, we're splitting the group up between male and female, and then over here we're splitting it up between sports and no sports that they play. I'm going to have you guys read through these really quick. You can pause it and read through, and then we'll move on. So our final answers on this one are going to be as decimals. It doesn't say where we should round them, but I'm going to round them to the nearest hundredth, since that's what we were doing on other problems as well. So we're going to round to the nearest hundredth here. The first one says we need the probability of randomly selecting a student from our two-way frequency table. If we randomly select a student, we need it to be a female. A female would be considered a win if we randomly selected one. So if we're doing win over possible, and I see that we have 27 females that play a sport and 9 females that don't play a sport, that means we have a total of 36 females. That's going to be divided by the total number of possible people that we could select from the group. Well, our sample size, it says right here, is 60 students. So we have 36 women out of 60 total students in our two-way frequency table. If we need to make this into a decimal, I'll need to divide those, and when you divide them, you will get 0.6. And that is it for that one. The next one is a little bit different. It says now we need, and by the way that these are written, this little p here is probability. And what's in parentheses is the probability of what's happening here. So for this one, we need the probability that the person that we select is a no sport person, doesn't have a sport, and is a female. So we need both of those things. Well, how many people in our table don't play a sport and is a female? That's going to be right here. 9 people don't play a sport. You can see that they don't play a sport because they're in that column, and they're a female. So now we have 9 people. That would be a win if we were to randomly select them. Over how many people are possible? Well, there's 60 people possible. 9 divided by 60 is equal to 0.15. And we are done with that one. The next one, this is something you guys haven't seen before. We have a line that's straight up and down. That is the same thing as using the word given. And I said given in my last video as well, so you might need to go check that one out. But given basically means this is happening for sure. So the way that I would read this, we need the probability of selecting a student that is not in a sport, given that they are a female. So basically, there's a 100% chance that the one that we're taking is a female. Given just the females, how many of them are not non-athletes? Well, to do this, we got to look in our female column, so I'm going to erase here for a second. Here's our female column. We have 27 that are in a sport and 9 that are not in a sport. We want the ones, the win in this case would be the ones that are not in a sport. So the no sport would be a 9. There are 9 females that are not in a sport. Out of possible. Now here's where possible is going to change, because the possible ones are the given ones. And it's given that we're only talking about females. So the males are not in this problem at all. It's given that we're talking about females. How many females do we have? We have 36 females. 9 divided by 36 is 0.25 or 0.25. And we are done with that. Notice though that the bottom is changed on those. My possible changes in this problem, because the first two problems are just talking about, in general, you're selecting somebody from the group. But on that last one, it changes because we're given that we're talking about females. Let's move on to the next one. At a school's open house, t-shirts and sweatshirts were sold. Each item was purchased by either a student or a parent. The two-way frequency table summarizes a random sample of 60 items that were sold that night. You guys can read through these to see what all these things mean. But again, we are going to need decimals as our answers. First of all, if I'm selecting somebody randomly, first of all, I'm going to change this up a second. I'm not going to use 27 and 9 because if you look up at the top, they were the exact same numbers up here. And I don't want to do the same problem over again. And we would get some of the same answers. So let's switch it up to 14 and 22. So I got to switch that up. There are still 60 items sold. Each of these numbers inside the frequency table, the 11, the 14, 13, and 22, those add up to 60. So there are still, I changed them, but I made sure that there are still 60 items sold. What is the probability that a sold item that night, randomly selected, belonged to a parent? Let's see here. So first of all, again, win over possible is the way that we're going to set that up. A win would be a parent-bought item. So for a parent-bought item, it would be 14 plus 22. Those are the ones that are bought by parents, 14 and 22. If we add those together, we will get 36. Over possible, well, for possible, that could be anyone. That could be student or parent. And there were 60 items sold. So 60 would have to go on the bottom. 36 items were bought by parents. That would be a win if we selected those. And 60 of them were sold total. If we divide those out, 36 divided by 60 equals 0.6. Moving on to the next one. Now we need a sweatshirt that's been bought by a parent. And then we've got that keyword "and" in the middle, so both of them need to be true. I'm going to erase here quick. There's only one spot on this two-way table that was a sweatshirt for a parent, and that is the 22 here. If we were setting up our fraction, the 22 there would be considered a win. Over how many were possible? Well, there's 60 items sold that night. 22 divided by 60. I'm going to round this here to get 0.37. That would be rounded though. The last one here, we have that up and down line again that I told you about last time. That means given. So we need to figure out the probability of selecting a sweatshirt that was bought by a parent. One more time. The probability of selecting a sweatshirt that was bought by a parent. Well, here were our parents. Oops, I didn't mean to do that. These were our parents up here. There were 14 and 22. T-shirts and sweatshirts. The sweatshirts we said was 22, so that would be a win. So we're talking about sweatshirts. Given that we're talking about parents, how many parent items were bought that night? Well, if you add up the 14 and the 22, we'll get 36. And if you divide those, 22 divided by 36, we get 0.61. Approximately, I rounded.